So continuing on from where we were yesterday, notes 224, we can just continue with these. You could make a note that it is actually notes 225 today. I changed the background up because people were complaining it was too tough on their eyes yesterday. We were talking about the mass of particles being in the AMU, kind of just summarizing where we are right now. If we change the AMU to grams, then we go from talking about the mass of individual particles to talking about the mass of moles. We talked about Avogadro's number being 6.022 times 10 to the 23rd particles are in a mole. We clarified what particles are, which would be atoms or molecules. With me, it's always just atoms or molecules. And it's important to understand this because you got to understand what kind of substance are you dealing with. Are you dealing with an element? Because if you're dealing with just an element, then which would be just one capital letter, then that means that the particles you're talking about in a mole are atoms. Okay. If you have more than one element stuck together, then you have a compound. And now what you're talking about is molecules. So for example, if I'm talking about 1 mole of sodium, just Na, then there's 6.022 times 10 to the 23rd atoms. If I'm talking about 1 mole of NaCl, then it would be 6.022 times 10 to the 23rd molecules, which would actually be different than atoms, right? Because atoms are within molecules. So that's often overlooked when we do this stuff, but it's important to understand that. So it's important to be able to understand what is the mass of a mole of a substance that I'm dealing with, because what you're going to be able to do is you're going to be able to go to lab tables with a balance, and you're going to be able to actually measure a substance and say, hey, this is this many moles. Or you can even go further and say, now that I know how many moles it is, I can actually tell how many atoms are in that substance I'm looking at, even though the atoms are way, way too tiny to see. All right? But in order to do that, we have to understand how to do scientific notation. And that's what we're going to work on today in practice. So today's success criteria is going to be that we can perform calculations involving scientific notation. So first of all, I just want to explain to you guys kind of the way I talk about scientific notation. You'll hear me talk about it the same way over and over again. We already have that it's a way of rewriting very large or small numbers. So you saw that number, Avogadro's number, 6022, followed by 20 zeros. If I lined up a bunch of big numbers like that, and I'm trying to compare them in terms of which one's higher or smaller or anything like that, it gets really tough to do. But if we write it in terms of scientific notation, it's not as hard to do. So I'm going to write Avogadro's number, which we could write as 6.022, or a lot of times you'll see it as just 6.02. Times 10 to the 23rd. So when you hear me talk about it, you're going to hear me talk about this front part, which I just kind of call it the normal part. Yep. And then there's just the times 10 part, which is pretty self-explanatory. And then we have this part up here, which is called the exponent. All right, so that when I explain things, that's what I'm going to be talking about. So how do we take really large or small numbers and change them to scientific notation? Well, first of all, I want you to understand what this times 10 means. So if you ever see, I'm going to do a couple numbers here. Like if you ever see 10 to the first, that just means 10. All right. If you ever saw 10 to the second, well, that's 10 squared, which is 10 times 10. That would be 100. You should write this down. Now going the other way, And this one's super important, so I'll put a couple little marks next to it. 10 to the 0. Any number with 0 exponent is equal to 1. So if I had 2 to the 0 power, it's 1. If I had 1,000 to the 0 power, it's 1. 1,455,632 to the 0 power is 1. Any number to the 0 power is 1. And we can even have negative exponents. Like if I had 10 to the negative 1, that would just be 0.1. But I just wanted to introduce you to that aspect a little bit about these exponents and what this times 10 means. We're not going to have to do a lot of tricky math calculations, really. The most you're going to have to do is multiply and divide. That's it. When it comes to the times 10 part, all this is really talking about is a decimal place and how many zeros we might have after a number, or how many zeros are out in front of a number, or something like that. So how do we write scientific notation? So let's say we have a large number, and I'm not going to make it too crazy. Well, maybe I will. Say we've got a number like this. And so if you're trying to count those, it's 525 followed by 7 zeros. Okay, 525 followed by 7 zeros. So step one, we're going to mark the original or old point. I'll call it original point, original decimal point. Mark or locate. And so in this situation here, if you look at the number, there's no decimal point in it. Okay? If there's no decimal point in the number, then that means it's really at the end. So what I'm going to do is I'm going to go to the end of this number, and I'm going to make a decimal point, and I'm going to mark it with a little arrow and put OP, original point. Step two is locate the first number from the left that is not a 0 and make a new decimal point after it. So if I look at my number up here, start to the left of the number, working your way across, the first number you come to that's not a 0 is the very first number in the number, which is a 5. So what my number is going to look like now is it's going to look like this. So I found that first number that's not a 0. I'm going to put a new decimal point after it. And I'm actually going to mark that with an NP, meaning new point. And then I'm going to write out the rest of the number like it was. 2, 5, followed by 7 zeros. And then, of course, we still have our original point there. Step 3, we can rewrite that number now. Now, it doesn't make sense if I'm trying to make this easier to understand and easier to write for that matter, to still write all those zeros. So I'm going to use this new decimal point. I'm just going to write 5.25. Now, all those zeros out there, they can be important in some situations, but when you're writing scientific notation like we are right now, just focusing on how to write scientific notation, they're not important. 5.25 is the same value as 5.25000000. Same value, doesn't matter. Step 4, write times 10. So now my number is going to look like this. 5.25 times 10 and almost done. Can I scroll down a little bit? So step 5, count number of jumps from new point to old point or original point. Okay? So if I do that up there, if I jump 1, it puts it behind the 2, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, there are 9 jumps. What that means is that 9 is the exponent. So now my number becomes 5.25 times 10, and to the top of the 10, I'm going to write a 9. Stop me at any time if something doesn't make sense. The last step, it seems like a lot, but once you do it a few times, it's a piece of cake. Exponent positive or negative? Well, it's important that we always count the jumps from the new point to the old point. It's important to remember that. Because if you go new point to old point, original point, to right, then it's positive. If new point to old point goes to the left, then the exponent is negative. So in this case here, when we went from the new point to the old point, we went to the right, so that means the exponent is positive. Another way to think about that is the exponent is positive when you have a really high number. So we had a really big number, 525 followed by 7 zeros. It's negative when you have a really low number, like some kind of decimal number. Something like that. All right. So I want to show you one of those, and we're going to go through the same steps we just did. All right. And then I'm going to have you guys see if you can do it. So here's a sample. Call it sample 1. And so instead of having a really big number that's hard to describe, we're going to have a really low number that's hard to describe. Then I'll do today's date, 2/25. All right. So if you're trying to count those zeros, it's 3, 6, 9, 0. So it's 0.9 zeros and then 225. So 0.9 zeros and 225. Okay? Yep, 9 zeros after the decimal. So 0 point and then 9 zeros and then 225. So if you were trying to say that number, it's not easy. You can't just say it's like 0.25 or it's 5/10 or 55 100ths or even 225 1,000ths. It's really hard to explain that number. But if you know scientific notation, it's not. So step 1, locate and mark the original point. If it's not in the number, it's at the end. Now this one does have a decimal point in it, so I don't have to put one at the end. I can just mark this right here as the original point. Next step, we're going to find the first number from the left that's not a 0, and we're going to put a new decimal point after it. So if I start from the left, working my way across, got a bunch of zeros. I have to go all the way over here before I get to one that's not a 0. So I'm going to put a new decimal right after it. So that'll be my new point. Getting this, Darren? So now I can rewrite my new number with the new point. With the new point, it's just 2.25. Ignore all the other stuff. After I write my new number, I can also write that times 10 part on there. So the only thing we're missing now is the exponent. And that's just counting the number of jumps. But we got to be careful to make sure we always start by starting at the new point and going back to the old point. So here's the new point here. So I'm going to go 1 jump puts me there. 2 jumps puts me there. 3, 4, 5, 6, 7, 8, 9, 10 spots. So there were 10 jumps. So that means my exponent is 10. So I have a 10 up here to the top right of the 10. All right, so we're done pretty much. But here's where everybody makes their biggest mistake. They know how to do scientific notation for a quiz, because we got to be able to do scientific notation for a quiz. They think they're done. But we got to check that last step. Is it positive or negative? In this case, going from the new point to the old point, I went to the left. That means my exponent is going to be negative. And so now I'm done. And see, we're just rewriting numbers. We're not changing the value. If you put this number in, 2.25 times 10 to the negative 10th, and you put that into a calculator, that would show all the zeros. A lot of times they don't. But if it would show all the zeros, it would come up with that original number, 0 point, followed by 9 zeros, and 225. Just like in that first one, if you put in 5.25 and you put times 10 to the 9th, it would come out with that 525 followed by 7 zeros. So it's the same value. It's just an easier way to write it and understand it. Okay, so now I want you guys to practice. Yes. Okay, so when you go to the new, you start at the new point, and you count the number of jumps going to the old point. If you go to the right, it's positive. If you start at the new point and you go left like this, like we did here, then it's negative. Okay. Yeah, and these numbers that have like the decimal point already in them, with 0 point some number, those are going to be negative. So when we were up there on the positive part, our new point was here. And then when we counted to the old point, we went to the right, didn't we? The old point is the one that we have right at the start without doing anything. That's the very first point we mark. Mm-hmm. And if sometimes numbers don't have a decimal point in them, and if that's the case, we just put it right at the end. Okay. So I want you guys to practice 2 of them, and then I'm going to come around and check them. All right? So I'm going to get ready to pause the video here in a minute. But for sample 1, we'll call this practice 1. Practice number 1. And I won't make it too crazy, but let's see how you do here. Let's go 7, 8, 2, followed by 4 zeros. Okay. Now that one actually wouldn't be too hard to say. We could actually call that 7,820,000. But we're going to write it in scientific notation. All right. And then practice number 2. Is going to be 0 point followed by 3 zeros, 9, 9, 1. And I am going to pause the video here. So you should write down in your notes practice 1 and practice 2. And you should attempt to do them. I'm going to come around and take a peek. Okay, so we're going to continue on. I'm going to work through these problems so you can check your own work. And if you didn't get it, go ahead and fill this in so you can see it again. If you did get something down and it turns out to be wrong, just make the corrections. But so in this first problem, first step is identify the original decimal point, which there is not a decimal point in the number, so make one at the end. So here's my old point. Okay. Next, I'm going to find the first number from the left that's not a 0, and I'm going to put a new decimal point after it. So coming from the left, first number I come to is 7. I'm going to put a new decimal point after it. There's my new point. Now I am going to rewrite my new number, and I can leave off the zeros at the end. So I'll just write 7.82. Now I'm going to write times 10. They're always times 10, by the way. It's never anything else. It's always times 10. And then as far as the exponent goes, remember that you're always counting from the new point to the old point, like you're working back in time. Okay? So start at your new point, go to your old point. In order to do that, I have to go 1, 2, 3, 4, 5, 6 jumps. My exponent is 6. Notice that we can't just count the zeros. You count the zeros, you're going to be wrong a lot. You're going to be wrong a lot more than you're right. Final check, is that exponent positive or negative? My original number was a really big number, by the way. And if I start at the new point and go to the old point, I'm going to the right, which means that stays positive. So that's my answer to number 1. Okay? On practice 2, find my original point. This one actually has one in it. So here's my original point. Find the first number from the left that's not a 0. So that would be the 9. Make a new point after it. Now I can write my new number, 9.91. And it's always going to be times 10. And then work back in time, start from the new point, go back to the old point. 1, 2, 3, 4. 4 is my exponent. Is it positive or negative? Negative this time. Going from the new point to the old point, I have to go left. There's my answer. Okay. So I told you guys when we do this stuff, it makes things easier to compare. So if we're going to compare numbers, so if I had these really huge numbers that were all written out, and I tried to compare what one was larger, I might have to count all those zeros and try to figure it out that way. But with scientific notation, it's really easy. If I have two numbers, like say Avogadro's number, and then I had this other number, say 677, followed by 20 zeros, which would actually be 6.77 times 10 to the 22nd. So I could give you guys this on a quiz and say, circle the number that's bigger. All you have to do is look at the exponent. Which exponent is higher? So compare this number and this number. That's 23. This is 22. This is a higher value. Even if I did it on a smaller scale. Okay, I'm not even looking at the front number. Front number doesn't matter. Just look at the exponent. This exponent is higher. This is the larger value. Now we do have to pay attention to if it's negative or positive though, right? Uh-oh.